Hey everybody, welcome to the Avalanche Developer Community Call. I am Gabriel Cardona and I'm very glad to be here with you today on Wednesday, April the 5th. Today we'll be talking about the upcoming Avalanche Summit, hoping to see everybody there in Barcelona. We'll also be covering the recent and upcoming Cortina Upgrade release and updates. And then we'll also be talking about some education and certification opportunities which we have been putting together at all the labs and hoping to share with the community soon. And I'm very, very stoked to be joined by three absolute block stars and champions of the Avalanche development ecosystem. First, we are joined by Patrick O'Grady, who is the VP of Engineering at Ava Labs. Next, we are joined by Stephen Butoff. Stephen was the first engineer ever hired at Ava Labs. He's also the head of the platform team and the creator of Avalanche Go and an absolute amazing engineer. Next, we are joined by Aaron Buchwald. Aaron, also one of the very first engineers ever hired at Ava Labs, recently graduated from Cornell, the creator of Core ETH, which is our instance of the EVM, and also one of the main engineers behind Stateful Precompiles, and I'm sure so many other things. Another amazing, amazing engineer. So thank you, gentlemen, for joining us. We appreciate your time. So first, I wanted to briefly talk about the upcoming summit. So from Wednesday, May the 3rd through Friday, May the 5th in Barcelona, Spain, we are having the Avalanche Summit #2. And we're predicting 300 speakers from all around the world, 125 panel sessions with multiple blockchain topics. And last year, there were around 4,000 attendees. It was an absolute amazing event. Last year was truly, truly a special event. If you go to a lot of crypto conferences, they're hit and miss, and this one was definitely a hit. It was absolutely amazing. One of the best conferences I have ever been to in my entire career, and we're hoping to, recreate the magic this year. So check out avalanchesummit.com, and you can still apply to speak if you're somebody who wants to get in front of the Avalanche community and a lot of the developers and the non-developers, like the entire breadth and depth of the Avalanche ecosystem. This is the place to be. So check out avalanchesummit.com. The event is in about 1 month from now, and we really, really do hope to see everyone there. I'm very, very excited. There's a lot of announcements I'm looking forward to, and just looking forward to connecting with everybody once again, since last year was so amazing. There's also an opportunity which we have been working on, where we want to offer people the ability to get certified as Avalanche developers. So, Avalanche is growing very rapidly, and now the subnets and virtual machines are really, really coming into focus. We expect, just so much progress to be made in 2023. And one of the ways, we're looking for many different opportunities that allow developers or teams to sort of surface above the noise and be genuine signals so that they can connect with, teams for job opportunities or funding rounds or other developers or other, entrepreneurs, let's say, to create teams and create amazing opportunities on the Avalanche ecosystem. And so one of the ways we've been brainstorming on is we want to offer the ability for people to, become certified as Avalanche developers. And we have a lot of different ideas that we've been tossing around here, and they're coming into focus. And we'll definitely be making some more concrete announcements coming soon. But we wanted to kind of plant the seed there right now and have people reach out to us, because now we're at a place in the process where I think we're able to start taking community feedback, or at least kind of getting a sense of what how people would like an offering like this, so that we can kind of dial it into focus. So if this sounds like something that might be interesting to you or your team, getting some type of official certification so that you can say, I am an official Avalanche developer. I went through this course. I met this certain requirements to become an official certified developer. Reach out to myself or somebody from the developer relations squad across one of the many different social channels, and we will share with you what we can, and then kind of potentially use you on the next steps as we bring everything into focus. So I did want to mention that as well. And of course, we briefly covered the summit. So now what I think I want to do is I want to pass the mic to, I think we're going to start with Stephen, where we're going to be talking about the Avalanche Go 1.9.12 X-chain regression. Stephen, would you like to take over?
Yeah, sure. Yeah, so I think it was a couple weeks now that we released 1912. So 1912 was designed to be kind of the final culmination of all of the work that we've been doing to prep the X chain for Cortina. And so there's been a lot of work going on for multiple years now on essentially the X-chain linearization, or it was originally talked about as X-chain epochs and then converted into X-chain linearization as we kind of spent more time researching and thinking about it. So I think if you actually look back at the very first timeline that we ever produced, we had X-chain epochs on there as scheduled for Blueberry. So we've been working on this for a long time, and 1912 was kind of the final piece to make the AVM compatible for both chain-based and DAG-based consensus mechanisms. And so the main part that 1912 relates to the incident was this refactoring to support both block and transaction-based state execution. So we did a pretty detailed write-up going into exactly which parts of the code were changed, and specifically what part of the code was changed incorrectly. But a quick summary of that is that the AVM has 5 different transaction types. There is the base transaction, which is essentially just simple transfers. There is the create asset transaction, which creates a new asset. There is the import transaction and the export transaction to basically send or receive funds to other chains in the primary network. And there is a last transaction, which is the operation transaction. So this incident focused primarily on operation transactions. Operation transactions are essentially functions being performed over UTXOs. So rather than a traditional flow check of consumed and produced UTXOs with just a simple balance check, the AVM actually supports essentially custom operations or like arbitrary functions over UTXOs to produce new UTXOs. And it was inside of this operation transaction that we removed a very critical part of the code where essentially we did not consume the inputs correctly to operations in the operation transaction. Operation transactions are notably used for things like minting new fungible tokens. So in a create asset, you can make like either a fungible token or a non-fund or a variable capped or a fixed capped token. If it's variable capped, then someone has the ability to say like mint more assets or things like that. And then the operation transaction also has to do with NFTs and properties. So specifically in 1912, what ended up being the issue was when someone issued an NFT transfer using an operation transaction, the state was not correct or canonical anymore across different versions because 1912 wasn't correctly deleting that UTXO from state. So once that was the case, we started to see nodes disagreeing on the state, which because of import and export transactions causes failures to essentially percolate throughout the whole subnet. So subnets are not, or chains inside of a subnet are not designed to be fault isolated, but subnets are designed to be fault isolated. So once the X chain started seeing issues, that can like spread through the import and export transactions to both the P chain and the C chain. So we ended up seeing a pretty severe regression due to this. It took us about probably like 45 minutes to an hour to actually find the concrete issue once pages started firing, which was actually well before the P chain or the C chains or even really the X chain started to see any major regressions on the network. But once we had found the core issue, it's pretty complicated to actually resolve the issue because of the DAG nature. So in an actual chain-based protocol, it's pretty easy to upgrade around a kind of fixed point on the network, whether it's like a block height or a timestamp or various things. Whereas in a DAG, because things are partially ordered, you don't actually have that fixed point to work around. So a lot of the following releases had to essentially introduce various small steps to get us to a point that we could get the network back to a position that we were happy with. So we're still we're still working on that progress actually. So there will be in the first release after Cortina, there will be some changes to fully finalize the full state across all nodes in the network. Because, for example, a node may have synced from scratch on 1912, and so we'll have to go back and repair those databases. But at this point, because everyone on the network is no longer using 1912, or at least the vast majority of people in the network are not using 1912, there's not really an active concern. But yeah, so 1914, 1915, and 1916 all kind of did their parts to get the network back into a spot that we were happy with going into Cortina. So that was kind of the issue. We really pride ourselves on having having extremely high uptime and extremely high reliability in the software that we produce. So I think we were pretty internally frustrated and disappointed about kind of how Cortina ended up being introduced to the world, because I think that we were all really happy with how it's coming together. But yeah, I think that going forward, we're just going to try to be better and continue to improve. But I think that that's kind of the summary of 1912. I don't know if there's anything else that either Aaron or Patrick want to talk about here, but
yeah, I mean, I think the one thing I'll say is at this point, to echo Steven's thing, is Cortina is meant to simplify a lot of the architecture and get everything running a single consensus. And so it was pretty ironic that in that process of trying to make things simpler and more stable, that there was instability. So naturally, we were pretty bummed about that, and we felt it was important to put out a public kind of postmortem or analysis of what went wrong, because we think transparency in anyone can do this. Obviously, anyone can observe the network and participate, but given our position as developers here, we felt more familiar with the metrics and everything like that. So wanted to share those because, as Avalanche continues to evolve into this platform of platforms, if you are building a platform on top of Avalanche, your own subnet, your own chain, but you don't have confidence in the underlying technology or the underlying aspects of that, which is, I think, especially more so the case in Avalanche, because when you're building, you're not just deploying a smart contract, you're building a whole chain. I think it can really rub people the wrong way. And so for that reason, we felt it was really important to really talk about this, as well as highlight the things that went well and didn't go well. And the things that didn't go well were, which we knew was a problem anyways, or a known issue, is that if a chain in the subnet fails, it can potentially impact the other chains in that subnet. However, as Stephen mentioned before, in terms of subnet to subnet issues, we were happy with at least what mostly was the robustness of that. And I pulled up this particular part of the blog post because I think it highlights exactly what I mean, which is, as the primary networks start to have instability, so when there's a large number of processing blocks, that typically means there's a lack of finality or a delayed finality. And at the same time, you can see on subnets during the same period of time, there was continued acceptance on almost all subnets. And so the folks that didn't have any acceptance were because when the processing spikes went up on the primary network, it caused the health checks to fail. And then a lot of API providers rely on that health check to serve traffic. And so if all of a sudden all the traffic stops coming to the nodes, unless you have some pathway that is direct to the node where you're submitting a large number of transactions, there wouldn't be any new transactions to actually execute. So we took an action item from that to create a more nuanced health check, and there's a public issue for that. I'm not sure exactly what number it is. And then the other thing is, as Stephen mentioned, trying better, which is pretty amorphous, which is we have started to run a number of what we call compatibility probes in our infrastructure to test, basically to continue running all previous or a number of previous compatible instances to be better alerted if there's an issue, especially during our testing, as well as to add some more acceptance criteria for publishing a release to the software. And so, the reliability of everything here is extremely important because the primary network serves as the backbone for a lot of other subnet related functionality. And so it's really important that the primary network is, as stable as possible, and then subnets themselves may be a little more aggressive and have more isolated failures, but it's core to the belief that the primary network should be, the most stable thing here. So, yeah, but that's it. Yeah, I mean, I think the reality of it is when you move, when you're pushing a lot of code, big changes especially, it's tough to foresee every possible change. And so I think our approach is there's a lot still to do on the Avalanche platform and a lot still to create. And so we could sit here and just say, yep, it looks good to me, like we'll keep it where it is, or continue to push, different sort of ideas that the community has brought up, or different changes to continue to improve the efficiency of the network. And so we've chosen the latter, and I think there's a lot of things that people have requested that will continue to push us in that direction. Cool. So that's the wrap up on the regression, X-chain regression. If you want to take a look at it, this is a public blog post. You can just search Avalanche Go X-chain regression, or I think we also tweeted it from a number of different accounts. Yep.
Excellent. Thank you. Yes, been tons of questions about that. So now we have a canonical source of truth. Please go check it out and share it around, because there were a lot of people who were interested in that. So thank you, gentlemen. So next, we want to pass the microphone back to Sir Patrick regarding the Cortina upgrade updates. So what can you tell us about Cortina, Patrick?
Sure. Yeah. So let me share my screen again. Let's see if we can do that one. Cool. Yeah. So, last week or 2 weeks ago when we had the last community call, we previewed the upcoming Cortina release before the actual public release information went out. So if you were here last time, you probably heard about that. If not, I'm sure you caught the news via different blogs and everything. The real thing is we are shipping basically the Cortina linearization we were targeting for actually to be activated on Fuji a week ago, but decided to delay it after the X-chain regression issue. But actually, if you run on Fuji now, make sure to update your validators before tomorrow, because the Cortina activation on Fuji actually occurs in just under 24 hours. At that time, the Fuji X-chain will become linearized, and then all P-chain rewards will be basically delegation fees will be deferred to the end of a validator's staking period. And so we're, obviously pretty excited for this. It's a continued journey of what's possible. I think the big thing, at least, I'll just do a quick overview of what the big three changes are, which is the X-chain linearization, which is converting the X-chain from a DAG into a linear chain running on top of Snowman++. You can read I'm not going to go through all the details here, but if you want to take a look at some of the reasoning for this, check this out. I think that the biggest reason is that migrating to a chain allows us to have a single form of consensus across the entire network, which is better for development efficiency. But in terms of actual usability, the DAG has at any particular point in time has no canonical or shared state between everything, because the DAG, let me give you a simple example, right? Let's say I have vertex A that's sitting right here, and this is going to be tough to do without me drawing something up. But vertex A, and then let's say at the same height next to it, I have vertex B. What is the shared state at that point? When I'm executing vertex A, I may not have even seen vertex B, which may modify something like that. And so if I use vertex C, and then vertex C is dependent on vertex A, but not vertex B, it may be unclear, is the outcome of B part of the shared state, and I just don't know about it yet? You could argue that because it's not apparent, but then maybe vertex D is created that relies on vertex C and then vertex B, and then what is this? So it ends up getting pretty complex to have some notion of a shared state. And what we've seen from a lot of developers is that most interesting smart contract functionality requires having some notion of this shared understanding of the world to do interesting really behavior. Example, a DEX is you're trading against a shared state object known by everybody. And so to add some really complex functionality to the X-chain, we're really excited now to have the capability to have some notion of shared state that people can rely on. Now you can try to build this with some sort of UTXO model, but we have in our conversations with a lot of developers have seen that they're not as excited about that and prefer to have some sort of account-based mechanism that they can kind of interact with, their like key value related store, rather than just straight UTXO smart contracts that are kind of linked together. The other thing is that Avalanche Warp messaging is only compatible with Snowman++. And so if we want the X-Chain to have any interaction with like Warp messaging and the subnet architecture, the DAG was just not going to work. And then I think really the last thing is that as the X-Chain continues to grow, one very important piece we wanted to get right was state syncing, because like as people sync their nodes to the network, the biggest question always is like, how can I sync my node faster, or how can I store less data? And right now with the DAG, you actually have to sync all historical vertices. And while it is possible, again, to create some sort of like state summary thing where like you cut off vertices from a certain point from being valid, it's quite a research problem. And so instead, we're going to use the Merkle DB that we've been working on for the Hyper SDK to power state sync, hopefully in the next release, like a V111 sort of approach. And that should greatly reduce the time it takes to actually synchronize the primary network as well. So I mean, I think that there's a lot of reasoning behind this. I think some people that haven't paid close attention to some of our code may feel like it kind of came out of nowhere, at least the X-Chain linearization part. But the work on this was actually started about a year and a half ago. In I think November 2020, I think is when or November 2021, I think is when we first started working on this. Is that right, Steven?
Yeah, so we originally started working on this like almost immediately under epochs, but I think once we decided to actually linearize the X-Chain and started work directly on that, it was like a long time ago. I think I could find the exact commit, but it's way back.
Yeah, so naturally that's like the biggest feature of this, and because this is such a huge change, we wanted to minimize the number of other changes in this particular release, just to try and the more you change it once, typically the more risky it is, especially in these sorts of networks. And so the other change was pretty minimal, related to the P chain, which is batching delegator rewards. And so as we've seen the growth of liquid staking, there's been a large increase in the number of delegators on the network. That's caused some performance issues and some APIs that the P chain used to expose, which are now modified to avoid having to iterate over tons and tons of state. But the other one is actually more related to the network itself, which is when the P chain was originally launched, anyone that was staking, someone could delegate to them. And then when that delegation period ended, they would then receive a fee for the work that they did for that delegator. Well, at that point in time, or when it launched and what it is today, is like you would get rewarded for each UTX, like each delegator would give you a UTXO. And because the delegation fee was typically pretty small and the delegation period is typically 14 to 28 days for most of these situations, a large validator may end up with thousands of like very, very small UTXOs as a result of their validation period. And so the feedback we got from people was, one, it's really annoying to build transactions using that many UTXOs. Second, it's really hard to track that many UTXOs for like taxes or accounting or whatever, different institutional clients are doing. And then third, our observation was, we're adding a bunch of stuff to the state. Let's probably not do that. All these additional UTXOs that are now being added to the P chain. And so the Cortina release instead pays validators all their accrued delegation fees at the end of their validation period in a single UTXO. So for large validators, this can mean a reduction of thousands of UTXOs to one. And so delegators, though, will still get their payout, obviously, immediately at the end of their delegation period. So this really only applies to validators. And so this should improve the UX of validators interacting with the P chain. They won't have to do as much like consolidation of UTXOs, as well as it should be better for the network in general, because there should be a lot less UTXOs created. And then lastly, very small one was that basically the C chain block limit has been 8 million gas since the launch of the network. Or roughly 8 million gas since the launch of the network. A number of folks basically mentioned that they couldn't deploy or interact or perform complex interactions with different contracts because the gas limit was too low. And so that is going up to 15 million gas. And the gas target, or how the fee is calculated per 10-second window, is not going to change at all. So the target will stay constant, but the amount of gas that a single block can include is going up by about 2x. So this will allow more complex contract deployments, as well as more complex contract interaction. I know that one team at least reached out, Trader Joe, saying that this would be great for their liquidity book stuff, because like a lot of the liquidity book stuff has some iteration over different state that can, in a really complex interaction, can take upwards of 8 million gas to complete. So this should be, good for folks that are doing things like that, or really anything in that nature that have complex on-chain interactions. So yeah, like I said, this is the code for Fuji is out now. So if you run anything on Fuji, whether that be subnets, your own validator, explorers, make sure you update. If you don't update, there are protocol optimizations in here that are incompatible with 19x or anything before it, and your node will disconnect from the network. And so if you see an issue with your node at that time, just know that updating will fix it, but you should update now if you want to avoid that issue. The Avalanche Go node will gracefully handle the activation for you. In the past, there's been confusion where it's like, all right, I'm waiting to upgrade till exactly the time that the upgrade happens, which is not what you should do. In some other networks, that's what you do. In Avalanche, the Avalanche Go client actually handles the migration for you. So it should be a relatively little or zero downtime event compared to, so that's the way it goes. And, based on how that activation goes tomorrow at 11 a.m. Eastern time, the timeline for the mainnet activation will be released. We're going to perform a bunch of testing after the activation occurs, and we, invite everyone else to also do some testing, especially on the revamped X chain, as well as on some of the staking related operations. So anything you guys want to add about Cortina? I know we already covered this a bit last week, so I don't want to talk about it too much. Aaron, anything you want to add?
No, I think you guys covered it.
Cool.
Okay, awesome. So we have a couple questions from the community. I just want to remind anybody who's watching in real time right now, if you have any questions, this will be the moment. If you want to try and get them in right now, please go to the YouTube real-time stream and drop them in the comment input field, and we'll see them here. Or if you go to social media and check out Avalanche Avox and see the announcement for this call, you'll get the Google input form, which you can input for next time we do this, which will be in 2 weeks. But if you want to try last moment to get some questions in now, go to YouTube live stream, put them in the comment, and we'll try and get them. Okay, so our first question says, where are we at? My friends keep bragging to me how awesome Polkadot's pre-built palettes are, since it allows for rapid development. Does Avalanche have something similar? If not, why not? If so, what is it? Anybody know about Polkadot?
So to provide some context here, palettes are basically these pre-built modules that Polkadot provides in their substrate runtime that lets you, perform common functionalities off the shelf. So, like for example, there's a governance palette. There's like a solidity palette. There's all sorts of different things you can kind of incorporate into your own virtual machine. This is not unlike a lot of the stuff Cosmos has done. If you look at the Cosmos SDK's X directory, which has like the bank package, or the bank, they call them apps. So the base, like the bank app, the governance or modules, I should say, the bank module, the governance module, the Cosm module, everything like that. And so the question is, like, does Avalanche have that sort of thing? Yes. So what we are working on now, and so the problem before the Hyper SDK is that we didn't have a kind of a container in which to write these different modules that people could use. And so it was not really possible, right? Like if you're building a virtual machine from scratch and I give you this module that handles governance, whatever that means in your use case, well, if you can't have a chain that actually runs it, like what good is the module? And so the whole point of the Hyper SDK in providing this sort of framework is that it is comparable to like a Polkadot substrate or a Cosmos SDK, in that it provides a harness to run a series of modules. Now, the modules we have so far are like warp messaging, different WebSocket streaming, a bunch of authentication and action modules, different RPC modules and stuff like that. Where we're targeting next is actually adding more interesting modules like a WASM related module, or maybe some sort of Oracle related module, or some storage related modules that we would add to the Hyper SDK. So it's been something that we've been very interested in for a while, but haven't had a great place to actually incorporate it into the developer experience. But the Hyper SDK will hold those. And we think that some of the best modules will probably be replicated between Golang and Rust related tooling. And so, we will have a lot of those. I think the difference is that Polkadot has been at this for a few years before us. So it's not unusual that they have, had more time to build different components out. But the way we approach it is, what do people ask for when we talk to them about like, why are you building on Avalanche, or, what's preventing you from building on Avalanche? And usually the case is, if you don't want the EVM, is I don't know where to start. There's too many options. Like, I get that it could be fully customizable, but maybe it's too customizable. I want some backbone provided for me. And so that was the Hyper SDK was the direct answer to that. And now that people have the Hyper SDK, the follow-up question now is, cool, the Hyper SDK exists. I want to do this. I want to do that. Like, I don't want to maintain it or code it myself. And that's where the modules come in. It's like easy ways to modify or change the behavior of this harness, which we call the Hyper SDK, to better suit your particular development needs. So I think the first big one, though, will be WASM related functionality. So people can actually run smart contracts inside of the Hyper SDK, which has overwhelmingly been the biggest question, which is, on Avalanche, if you want to run smart contracts, they're really the only paved road is the EVM right now. And I think a lot of people, WASM has become popular because you can use your own languages to actually compile down into WASM, like a Rust or a C or C++, and then not really worry about, anything else behind the scenes. And the chain itself can run all of those things. So let's just say we have the framework for it now, and that took quite a bit of time to get to the right place. We don't have as many like pre-built palettes yet, because the module harness that runs them is still pretty new, but it's very much something we're interested in providing to people. Yeah.
So everybody go check out hypersdk.xyz, because this is really, really cool. Patrick has poured a ton of energy into this, and it's definitely something we want to get into the hands of developers. It's something which can really set Avalanche, the network, apart from other networks and other competitors, because right now, it's clear that the EVM has pretty much won as the engine of DeFi in the moment. But of course, the blockchain has so much untapped potential, and having something like the Hyper SDK, which unlocks so much of Avalanche's, built-in potential, but being expressive enough to allow people to create all different manner of hyper VMs on Avalanche. Once this starts flowering, it's going to be really, really exciting. We're going to see a total renaissance of blockchain tech, and this is a big enabler. So hypersdk.xyz, go check it out right now. So the other question we have, that was from Kajan. Thank you, Kajan. This next one is from David Kanar. This says, is it possible to access the AVAX bridge using code? What SDK should we use to accomplish that? So is it possible to interface with the bridge programmatically?
Yeah, so the bridge, it's deposits and withdrawals and everything. It's like deposits into the bridge and then withdrawals from Avalanche out back to the origin network are all based on code interaction, or like on-chain interactions. There's no like API you call at the bridge to like have it kick off something, right? It just watches the chains and then performs actions as a result. So can you interact with it directly using code without anything? The reason why, and there's facts online of why it's not recommended per se, is that the addresses that are used for the bridge to custody funds are rotated on a regular basis for security related reasons. And so the address that you may hard code may change. And so if you're using the front end, which ensures that that stays up to date, you'll never need to be concerned that you like send it to the wrong bridge address, which would black hole the funds. So if you want to, though, interact with it, There are ways to do it. Coinbase, for example, is integrated with the bridge and lets people mint and basically go back and forth on the Avalanche bridge. So it is possible. You just need to be very careful about making sure that you stay up to date on what addresses are currently being utilized for that. In terms of an SDK, I'm not actually sure if there's a public SDK that people use. We'd have to follow up on that one. I think there may be. Yeah, I'm not sure there's a public SDK for that, but we can, Gabriel, maybe we can take that as an action item on the DevRel side to figure out if there is.
Sure, absolutely. We'll see if there is, and either follow up on social media or we'll mention it next time on this particular call in a couple of weeks. Okay, so it seems like a couple of other questions have come in here. How about X-Chain dynamic fees? Question mark.
Yeah, so I think can I still hear myself? No, okay. Yeah, so I think Patrick had mentioned that we'll hopefully get StatesYnc in on like V1.11. I think that there's a couple other major efforts ongoing. So there's definitely some staking improvements, further improvements that we're working on. And then there's also some adding support for dynamic fees both to the P chain and the X chain. So right now our fees are pretty high in general on both the P chain and the X chain because they're essentially set as like a bound on like what we would expect any reasonable load to be. But in reality, like that often ends up overcharging for usage. So yeah, we'll definitely end up introducing dynamic fees as soon as possible. Might even be before introducing StatesYnc, but it kind of depends on like how the development goes for all of these things. They're kind of independent features, even though they all touch on like the P chain and the X chain. But yeah, definitely dynamic fees and StatesYnc and further kind of staking improvements are kind of a major focus for both the P chain and the X chain right now. So yeah. So I don't know exactly on timelines. It kind of
I mean, the way that we think about phases of the network is stable. Like, so we're in this process. We're now linearizing the X chain. After that, it goes into basically P chain continuous staking, so like making it easier to stake, so you don't have to keep restaking things, as well as adding a little bit more control or like kind of dynamic. I can't say the word, but like making fees dynamic on the X chain and P chain to better reflect different activity. So like in times when there's not a lot of load, it should be cheaper. In times when there is, it should be a little bit more expensive. So once those are really done, or that's like the major components of the primary network, and then the last thing is like not the last thing. This will be going for. But the other thing that we got to do is better connect the subnets to the primary network and allow people to warp in and out of the primary network. That has probably been outside of continuous staking, one of the largest feature requests has been how can I better move between those. Maybe I want to have a staking token on the primary network, and then I want to use it as the gas token on my subnet, or I want to use Avalanche as the gas token on my subnet. And so, but it's, step by step, these are all huge changes. And so the faster you push all at once is typically just asking for, some issues if you're not fully testing everything. So it takes time to get quite right, but we really like where the network is at now and kind of the future plans for it in terms of what people have asked for. And, even today we saw SK Planet decide that they're going to build subnets on top of Avalanche as well for the Korean market, which is a huge deal for us as well as for, I think, people there. And one of the big reasons was the subnet technology they feel like is really great for their use case of having their own token, having their own virtual machine, having all the stuff that you would hope when you have your own blockchain, but at the same time remaining basically retaining interconnectivity to the rest of Avalanche. So using warp messaging. So I think that should be pretty cool. But yeah, so that's my result unrelated to X-Chain dynamic fees. So I'll turn it back to you, Gabriel.
Awesome. Very, very exciting. Okay, so we have time for one more question. And we're going with, first off, great work on the Hyper SDK. And what are your favorite live enterprise use cases for subnets on Avalanche?
Yeah. So when we talk about enterprise, I think of I guess I wouldn't include gaming in this, but my favorite, I'll answer the enterprise specific component of it is the gaming side of it. So I'm a big gamer. I enjoy playing different games like that. And I think like the internet native or, digitally native games that truly give ownership and participation rights to the participants using a blockchain is a really cool extension of like what is the digital world that people are trying to create. It just feels a lot more real to me. And so we've really been excited about the different sort of gaming things people are trying to accomplish. And a lot of the thinking in the Hyper SDK has been, how do you take a game that is extremely high throughput and actually put it on chain? The EVM is not quite suited for that task, even in the rollup world, because of all the data you have to put onto ETH-L1. Like the max TPS across all rollups on ETH-L1, even with EIP 4844, is on the realm of about 1,000 TPS. If you're going to put all games or like a bunch of games on a different rollups, it's not going to be possible with that throughput to achieve what you want to achieve. And so with each subnet, imagine you can hit 10,000 or more TPS, and you can have 20 subnets. You can see that the global throughput, regardless of how security is provided, it's just not even tenable on some solutions. And so we've been very encouraged by the uptake in subnets because of that high throughput use case. In terms of enterprise use cases, though, I think a lot of people have been particularly interested in it for tracking different reward use cases and reward points. I think that's what SK Plan is going to use it for, is like having a distributed market of like points that can be traded around. Like let's say you earn points from your airline and you instead want to trade your airline points for like Starbucks or something like that. I don't know. I think that's been one of the ideas people have tossed around as an interesting one. I think the other one is probably kind of a new, my favorite. That's the points one is probably the most common use case I've heard. My favorite, though, is actually replacing all notions of like registrars or domain registrars with a blockchain. So like basically you can publish updates to a name server or publish updates to code or really just anything that needs a source of truth for either security or just generally avoiding like this huge like legacy DNS thing to have a different solution that is a little bit more community owned. We've seen a lot of people start to progress on that, but I don't think it's really taken off in the same way. And so I'm hoping that the internet native folks that want to really retain ownership of a namespace as well as publish data to that namespace will use blockchains at some point here. But that's my favorite one that we're interested in. I haven't seen as many people uptake it yet, but that's what I've been excited about.
Just to touch on that last thing, if there's any devs out there that want to just lose all confidence in the internet, I recommend highly digging into DNS and like all of like the routing protocols in the internet. It's terrifying. So anyways, I would be a huge fan to see any of these things adopt more.
The master key signing ceremony is pretty wild, right? Don't they have like physical keys for they have like little hardware wallets basically, and they all have to bring them together into one master room and put them together or something like that? Or is that just from a movie?
Dude, it's
who knows, man. I mean, I think that the thing is like with a lot of these sort of solutions is, many of them were created 20, 30 years ago, and people have been terrified to change them because so much relies on it, right? Like, and there's so much compatibility, right? If you change DNS, like, I mean, every internet device in the world is hard coded to believe DNS works a certain way, right? So talk about a migration. You're talking like a couple billion device migration effort to like change it. So whatever you're going to do better really be pretty good. But I think that what we like to see is an alternative where, I think in a world where security ends up being so much more important, one really cool use case I think is going to be super interesting is to have like a like a signature database kind of authenticated builds almost. And so people can publish hashes of builds for different software programs. Let's say, your latest release of Core, or your latest release of MetaMask, your latest release of Avalanche Go. And then different people in the community can just decide to sign those releases. And so you can keep track of on a website, like who has actually authenticated or attested that that is a legitimate release. And then any computer in the world should be able to just check this registry and say, like, have some confidence, hopefully, whether or not that like build is correct based on some form of source code. So like those are the type of things that I think would be really cool, which right now totally rely on centralized services. Like when you download an app into the Google Chrome store, who's it going to ask if it's valid? Google's an arbitrary API, right? Like what if that API is like hacked over? Well, you probably just lost all the money you had in your MetaMask account. It's never happened, but doesn't mean it won't happen. And so the idea that we can rely on just general, more accessible cryptographic solutions seems to be a pretty exciting use case regardless of that. So
Yeah, I love that idea of these sort of like registries, because one of the things that I ultimately envision in this world where subnets and virtual machines are totally successful is I've always really loved like the Unix philosophy of having these utilities that are very simple and do one thing really well and have these very clean and crisp interfaces, and then people can come and place them together like Lego pieces and put together, nice little scripts. And that same philosophy definitely has sort of bled over into a lot of modern programming where you have package managers and you have things like, a package JSON file for Node.js or, the equivalent in all the other different languages. And then you have like a lock file. So, all of your dependencies and, all the different versioning, and it's very clear how everything's fitting together. And that's one of the cool things about Web3 as well, how you're able to be very modular with your architecture and build upon different contracts, which you can build upon and call other contracts. And it's very, very cool in that way. And I envision the same thing ultimately being true for virtual machines and subnets, especially with Avalanche Word Messaging. So I can imagine this future where there's all these subnets and they do one thing very well, and they have these very clean, crisp interfaces. And then through using word messaging, subnets are able to build upon other subnets or call other subnets, and people are able to come together and just put together these really, really dynamic workflows that interface with a bunch of different subnets and somehow make it all work through this word messaging. And then this idea of registries, of course, plays into that because you could trust the different components that you're calling, because they're versioned, they're following something like semantic versioning, and they have signed commits and, et cetera, et cetera. So very, very cool vision. I think that's about it. I want to pass the mic around one last time and get last minute thoughts and where people can find you online. So if you want to plug your social, let's start with Steven. Steven, last minute thoughts and where can people find you?
So last thoughts, probably just looking forward to the Fuji activation of Cortina tomorrow. Super excited to see how that goes, and finally seeing all of our work starting to kind of come to fruition. So really looking forward to that. As far as online stuff, I don't really have a huge online presence, so maybe reach out to me in the Discord, or you can follow me on Twitter, even though I never tweet. So that would be.
You can send
yeah.
Steven
What's your Twitter handle? It's
just Steven. So.
Okay, go check him out, y'all. All right, next, Darren, thoughts and where can they find you?
Yeah, I guess final thoughts are really just I'm really excited for us to be starting to push out more public roadmaps and talk more with the community. I think we've got a really great vision for how you can build blockchains and just secure distributed systems in general in a seamless, interoperable way. So really excited to share that more with the community and hopefully explain exactly what we're thinking. And I hope the community really likes it and gets excited about it, so we can just start sort of marching in that direction and hopefully get some help from the community too, because that'd be amazing. The community can find me on Twitter at Aaron Buckwald. I think that's my Twitter profile, but not 100% sure. Not huge there either. Yeah, that's it for me. Thanks, Gabriel.
Yep, thank you as always. Patrick, Pog, thoughts and where can they find you?
Yeah, just been working a bunch on the Hyper SDK DevNet stuff to test out the MerkleDB and everything. I wanted to release it, public DevNets maybe a week or so ago, but have decided to spend a little bit more time on performance engineering to make sure that the TPS people can run into on DevNets is what they expect, and make sure that their resource usage is, as low as we can get it at this point in time, at least with an alpha stage project. So just working on that, helping out with the Cortina stuff, and then wanted to plug this pretty cool cube thing that I got. So I was talking to, if people know Bram Cohen, he's one of the, I think he's like the head of Chia right now, but I ran into him the other day and he was like, hey, like I actually designed these like really cool puzzles. And so I checked it out and it's an awesome like thing I mess around with on my desk, but that's also been something I've been playing with this whole call. So just to keep it interesting. Yeah.
Who is it? Brandon what?
Bram
Oh,
Cohen.
Brand. Oh, okay.
Yeah.
Nice
guy, but he's really good at making puzzles. So
Sweet.
Okay, did you plug your Twitter? I'm sorry, I didn't catch it.
yeah, my Twitter is _ So like someone has the original Patrick O'Grady, so I didn't want to do the Patrick O'Grady, but so I'm _ Patrick O'Grady on Twitter and on Medium, I guess.
All right, go check him out. And so lastly, a couple, I wanted to again plug the summit. So go check out avalanchesummit.com. It's in 1 month from now, Wednesday, May 3rd through Friday, May 5th in Barcelona, Spain. Going to be absolutely amazing. Last year was genuinely one of the best conferences I've ever been to in my entire career. This one's going to be even better. So come and see us all in Spain. We hope to see you there, avalanchesummit.com. And I also want to mention that we are hiring across the board at Ava Labs. We're definitely looking for people who are just incredibly excited to have a radical impact on the world with blockchain technology. We're building the Internet of Finance. We're really working with some amazingly cool stuff, as you can see from the conversation today. But we're not only hiring engineering, we're hiring genuinely across the board. So go check out avalabs.org/careers, and you can see all of the different current openings that we have. Myself, I'm Gabriel Cardona. I'm a developer evangelist at Ava Labs. You can check me out at CG Cardona. That's Cardona. So CG Cardona on Twitter. And we will be back here in 2 weeks. So thank you, everybody, for your time. Thank you again, gentlemen. Thank you, Ava Labs, for the opportunity. And thank you for all the amazing developers out there. We're incredibly grateful. We wouldn't be doing anything if it weren't for all of you building upon the Avalanche network. So we're really, really looking forward to seeing all of the cool stuff that's being built. And hopefully we'll see everybody in Spain. Either way, we'll see you guys back here in 2 weeks. So thank you, everybody. Cheers.
See everybody.
Thanks, guys.